So the next question is called as your switching modulator. So what is meant by switching modulator? You know that switching modulator is a generation method of your AM modulated wave, low level amplitude modulated wave. One of the frequently asked question is explain in detail the working of switching modulator with diagram and necessary derivations. Okay, so first let me tell an overall view of this circuit. The circuit diagram mainly consists of three sections. So your first section is going to be your summer. Okay, so this is called as your summer. So it adds the two signals. What are the two signals it's going to be getting added? One is your message signal M of t, that is your low frequency signal, and second one is going to be your high frequency signal, that is your carrier signal. The addition of both will be given as Vi of t. So here you have the expression Vi of t is equal to M of t plus C of t. So you know that C of t is represented as AC into cos 2 pi FCT. So I can tell that Vi of t is equal to M of t plus AC into cos 2 pi FCT. So this signal will be given as input to the next section, that is called as your switching element. Here the diode is acting as a switching element. The nonlinear device, that is your diode, will be acting as a switching element, provided the diode which is going to be used is ideal. It acts as an ideal switch which represents zero resistance during the forward bias and infinite impedance or resistance during the reverse bias condition, right? So your output of the diode is taken as your V naught of t. So this output diode, the assumption taken here is your carrier signal amplitude is very larger. So your V naught of t will depend upon your carrier signal. That's the reason why you have the expression V naught of t is equal to Vi of t when C of t is greater than 0 and 0 when C of t is less than 0. Okay, so it is acting as a switch. The output V naught of t will be given to your band pass filter, which will eliminate all other unwanted frequency signal, and it will give you the desired modulated signal, that is your S of t. Okay, so this is your overall overview of this diagram. Moving on to the next slide. So in the case of mathematical analysis, as I have mentioned before, the magnitude of the modulating signal is assumed to be smaller than the amplitude of the carrier signal. Therefore, the output of the diode is controlled by the carrier signal. The diode is forward bias, means what? It acts as a closed switch when C of t is greater than 0, and reverse bias, that is open switch when C of t is less than 0. So it is given by the expression V of t is equal to Vi of t when C of t is greater than 0 and 0 for C of t is less than 0. This same expression can be written as mathematically the output of the diode is given by, we can write that V naught of t is equal to Vi of t into your rectangular pulse train. So which is represented as Gp of t. So this is your diagram of your rectangular pulse train. So where P of t is the rectangular pulse train with period which is equal to capital T naught, which will be equal to 1 by Fc, and which is having a duty cycle, 1/2 duty cycle, right? So the Fourier series representation of this rectangular pulse train, how it can be written? Gp of t is equal to 1 by 2 plus 2 by pi into n is equal to 1 to infinity minus 1 power n minus 1 divided by 2n minus 1 into cos 2 pi fct into 2n minus 1. So if I expand this equation, that is, you can give the value for n is equal to 1, 2, 3, etc. So I have given this n is equal to 1 and n is equal to 2, and I have expanded the formula, which can be expanded as, which is equal to 1 by 2 plus 2 by pi into cos 2 pi fct minus 2 by 3 pi into cos 6 pi fct, plus you can give n is equal to 3, it goes on. Okay, so let us make the analysis short, taking the first two terms. Okay, so now you know what is the value. Substituting, you know what is Gp of t. If you substitute this Gp of t in your equation 1, okay, instead of Gp of t, you are going to substitute the value. Therefore, V naught of t is equal to, you know that, Vi of t into Gp of t. Now you are going to substitute the value for Gp of t. So when you substitute the value, what you will be getting? V naught of t is equal to Vi of t into, you have substituted the value for Gp of t. So Vi of t, but already you know what is your Vi of t. Vi of t, the summer output, right? M of t plus C of t. So can you substitute the value for Vi of t in this equation? So you will be getting V naught of t is equal to M of t plus AC into cos 2 pi FCT into your Gp of t. Next, what you're going to do is you're going to cross multiply it inside. So m of t into 1 by 2. That is, you have got 1 by 2 into m of t. Then you are cross multiplying m of t into 2 by pi into cos 2 pi fct. That is your second term. Then you are going to multiply AC into cos 2 pi fct by 2 you will be getting, right? AC third term. And the fourth term is going to be AC into 2 divided by pi into cos square 2 pi fct. So already you know what is your cos square theta, right? So you have here 1, 2 and here you have cos square theta. So you know that cos 2 theta is equal to 2 cos square theta minus 1. So what will be your 2 cos square theta? 2 cos square theta is equal to cos 2 theta. Here it is not minus, here it is plus 1, right? So you are going to substitute the formula here. Instead of 2 cos square theta, you are going to substitute it as cos 2 theta. So it will become cos 4 pi fct plus 1. That is what the second substitution. So when you cross multiply it inside, you will be getting 1 by 2 into m of t, 2 by pi into m of t into cos 2 pi fct plus AC by 2 into cos 2 pi fct plus AC by pi, that is into 1, and AC by pi into cos 4 pi fct. So actually what should be your modulated signal? Modulated signal should be having your both the sidebands and your carrier signal, right? It is also called as AM is also called as DSB full carrier, double sideband full carrier system. So your second term and your third term is going to be your desired modulated signal, that is which is having m of t into cos 2 pi fct and your carrier signal as such. So this is your desired modulated signal. So if I want to retain this signal and I have to eliminate your all other unwanted signal, I have to pass it through a band pass filter. So the output of the band pass filter will be equal to your 2 by pi into m of t into cos 2 pi fct and AC by 2 into cos 2 pi fct. So this is your overall output, which is nothing but which is equal to, which is looking same as that of your general expression, that is AC into cos 2 pi fct plus AC into Ka into m of t into cos 2 pi fct, except for the scaling factors. So this is going to be your output equation. Okay. So now if I want to take a Fourier transform spectrum, so what will be a Fourier transform? V naught of t will be converted to V naught of f. So you'll be getting 1 by 2 into capital M of f. Then you will be having m of t into cos 2 pi fct. You know what is the formula? M of f minus fc plus m of f plus fc divided by 2, right? So here you will be having, actually you will be having here 1 2 and in the numerator here you have 2 2 2 will get cancelled. That's the reason why you are getting 1 by pi into m of f minus fc plus m of f plus fc plus what is the next parameter? AC by 2. So you know that what is the formula for Fourier transform of cos 2 pi fct. So you know that del of f minus fc plus del of f plus fc divided by 2, right? So you will be getting here, you have a 2. So you will be getting AC by 4 into del of f minus fc plus del of f plus fc, plus your next term is your AC by pi. So AC by pi into del of f. Then the last term is going to be AC by 2 pi, right? So what will be your cos 4 pi fct? Del of f minus 2 fc plus del of f plus 2 fc divided by 2. That's how you're getting the last term. So this will be your frequency domain representation, or your Fourier transform, or taking your Fourier transform. So next we will see how to draw the spectrum. So if I draw the frequency spectrum, so what will be your frequency spectrum of the signal? If I draw this as V naught of f, what are the signals which you will be getting? You will be having your message signal, right, with minus W plus W spectrum. So what will be your amplitude? 1 by 2 into m of 0. Next you will be having your carrier frequency, right? So plus fc, here you will be having minus fc, right? So what is your amplitude? AC by 4, right? So AC by 4, Here also it is going to be AC by 4. Then you will be having the two side bands. One is your upper side band, the other one is your lower side band. So what will be your value here? FC plus W, and here it is going to be FC minus W. Similarly, here it is going to be minus FC plus W minus FC minus W. Right. So what is your amplitude value here? 1 by pi into m of 0. Similarly, here also it is going to be 1 by pi into m of 0. Okay. Now you have, in addition, you have center frequency plus 2fc, and here again you have minus 2fc. What is your amplitude? AC divided by 2 pi. AC divided by 2 pi. So this is your output spectrum of your that is V naught of F after the diode output, right? So if I pass a band pass filter, I can get my modulated signal. I can retain the modulated signal, and I can eliminate all the unwanted signals.